So in fact, today we have two contents. So this is the first content, and later I will introduce our second content. Okay. So because today is the last lecture of this class. Okay. So today's content is a function, declaration function, and recursion. So do you know the meaning of the recursion? Recursion. You don't know? So anyway, I will introduce. So actual content, today's content is as shown here. The function and declaration function. I introduce the example program, and I will explain the recursion. And I will also introduce some program using a recursion call. Okay? And finally, I'll introduce today's exercise of the first contents. So already I introduced some function, such as a standard function, file input output function, and keyboard input output function. For example, scanf function, printf function, and fprintf, fscanf, and so on. So however, if you need, if you have to define the several procedure, and such procedure are frequently used. So in such cases, you have to define such procedure as one function, special function. Okay. So as shown here, why new functions are necessary? As I explained, it is very convenient if frequently used procedure defined as function. So already I introduced you can use a standard function. Okay. Of course, before using your dedicated function, you have to define the function for you. This is the general form. First, you have to put a return type. Okay. So every function has a return type. Okay. And function name and argument list. Okay. So inside the bracket, you can define the several functions and several procedures. Okay. This is a simple example. This is the addition function. Its function name is a plus, and return type is integer. And argument is two arguments. So first argument and second argument are both integer type. In this case, it's A and B are variables treated as arguments. So especially these variables are called local variables. So local variables are only available on inside the function. Okay? So this function is very simple, only return the addition of A and B. Okay? So this is another example. In this case, this function returns some mention of some integer type data. So such data is given as array data. Okay? So array data, you have to specify the array data as an argument. No. You have to specify, if you want to use the arguments as array data, you have to use a pointer type data that refer to the such array data. Okay? So in fact, D is array data. However, if you use such a data as an argument, you have to specify its a pointer. Okay? And second argument is the size of the data, array data. And using a for loop, you can add each element of array data one by one using the plus equal. Plus equal means the substitution of y is a local variable, and ti is one of the data data specified by index I. And finally, this function returns total value. Okay? Of course, you have to specify the main function to calculate the actual problem. So in this case, it's two array data prepared. And using the sum function, you can calculate the total number of each array data. So if you don't declare the sum function as a function, you have to write the program, this part, duplicate several times. Okay? So however, if you define the sum function as one function, you can calculate the sum of two array data only by calling the sum functions. So this is the content is completely same as the previous one. However, the definition manner is some difference. So in this case, first you declare the prototype definitions for some functions. Okay? So before our main function, you have to specify the prototype definition. Because if you use the sum function inside the main functions, the main function has to know the return type and the argument type for some functions. So before using the sum function, you have to specify the prototype definitions. And the actual definition of the sum function is located here after main functions. So if this part is located before main functions, you don't need to put prototype definition here. So do you have any question about the definition, declaration about function? Please?
What does the star mean?
Star.
It says integer sum,
Yeah.
integer star.
You mean here?
Yes.
Star. So actual call path for sum is here. So data one is array data. So array data. Each element is integer type. Actual declaration is here. Okay? So inside the memory, so inside the memory, data one is prepared like this. First element, second element. Each data is an integer type. Okay. So each element has a corresponding size. For example, 4 bytes. Okay. So in this case, the variable name data one is actually treated as a pointer for refer to the location of the arrays. Okay, so this argument data one is in fact a pointer. Okay, so for declaration of the new functions, the first argument should be pointer. So you need a star. Okay? Okay? Can you understand? So next I'd like to introduce recursion. Okay? So already in mathematics, you learn the recursion. So for example, factorial. So do you know the factorial of integer n? Okay. So usually the expression is here like this, n exclamation mark. So of course, n should be larger than 0, and 0 or larger than 0. So factorial 0 is 1. This is a definition. Okay. Okay. And factorial 1 is 1. And factorial 2 is 2 multiply 1, so should be 2. Okay. So in this way, the factorial 3 should be 6. Okay. So you can define the factorial using a recursion. Okay. So this is the definition for factorials. The argument n is is 0, if 0. In such cases, such factorial should be return 1. Should return 1. Okay. And if n, argument n, is larger than 0, in this cases, factorial n should be n multiplied by factorial n minus 1. Okay. So in these cases, this part is also factorial. The however argument is different, n minus 1. So in this way, so this is a definition of a factorial n. Inside definitions, also definition of factorial n minus 1 is used. Recursively, factorial is called. Okay. This type of function is the recursive function. Okay. So can you understand? Okay. So this is a definition of the factorial. So if you declare the program as a function, you can only declare this definition as a program. Okay. So this is actual program. Very simple. In this case, return type is an integer, and the function name is factorial. The argument is only one argument. Its type is an integer. Okay. And so this is a definition of the function factorial. Okay. So this part is correspond to this definition, and this part is correspond to this definition. Okay. So very easy to understand. If n equal 0, in such cases, factorial should return 1. So this function also return 1. Otherwise, in this case, n is larger than 0. Then factorial n should be n multiplied by factorial n minus 1. So inside the program, n multiply factorial n minus 1. In this way, factorial is also called inside the function, same function. However, argument is of course different. If the argument is the same, such program will not be stopped. Okay. Please.
Why is this one return 1?
Return? Pardon?
Usually it's return 0 on that one.
Pardon? Pardon? Return.
Return 1.
return 1. So this is definition. So this is mathematical definitions. Okay? Factorial 0 is 1. This is mathematical definition. Okay? So do you have any question? Can you understand? Okay? So this is a definition, mathematical definition of a factorial. And this is a declaration for function for factorial in a program, other program. So very easy to understand. Okay? So here I'd like to explain how to execute inside the program for factorial function, especially factorial 3. Okay? So in main program, if you call factorial as argument is 3. Okay? So in this case, n is a 3. So first part is not true. So this part will be executed. So in this case, n minus 1 is a 2. So recursively factorial 2 will be called. So you have to, the program have to calculate factorial 2. So this is the second step. So the program have to calculate the factorial 2. In this case, n is a 2. So this is false, this is true. So n is a 2, and factorial n minus 1, this means factorial 1. The program also calculate factorial 1. So third step. So in this case, n equal 1. So this is false, this is true. So this part will be executed. In this case, n minus 1 equals 0. So recursively factorial 0 will be called. So program have to calculate factorial 0. Okay? So in this case, n equals 0. So this part become true. Okay? So program return 1 as the result of factorial 0. Okay? So factorial 0, the program find the result of factorial 0 is 1 as 1. So the program return the previous step, step 3. So factorial 0 is 1. So the program calculate 1 by 1. This corresponds to this. Step 3 is this part. Okay? So of course, the program also calculates the result of factorial 1. Its value is 1, because 1 by 1 equal 1. 1 multiplied by 1 is 1. And so this program finds the factorial 1, a result of factorial 1. Its value is 1. So this program also can calculate the factorial 2 using these expressions. N is 2 and factorial 1 is 1. So 2 multiplied by 1 equal 2. Okay? And the program return to the first step. In the previous execution process, the program can calculate factorial 2. This return value is 2. So 3 multiplied by 2 equals 6. Okay? So as a result, program can calculate the factorial 3. Its return value is 6. So can you understand how to execute about the recursive function? Okay? So actual program for factorial is here. this is a definition, declaration of factorial function. And this is the main function. I also introduced another recursive call function. This case is summation of 0 to n. Okay? So maybe you can imagine, you can understand as a so because summation n can be defined similar to the definition of the factorial. Okay? So n, if n is 0, then summation 0 equals 0. And otherwise, n is larger than 0. The summation n equal n plus summation n minus 1. Okay? Can you understand? So this is a definition of mathematics. So as a program, you can declare some function, as shown here. So if n equals 0, then return value is 0. Otherwise, the return value should be n plus summation n minus 1. Okay? So this is the main function. And the last example of the recursive call is GCD. GCD means greatest common divisor. Okay? So the famous algorithm is Euclidean algorithms. So this is the mathematical definition of Euclidean algorithm. So in this case, so you have to give two integer numbers, a and b. So anyway, a should be larger than b. Okay? And if r equals 0, r is a remainder of a divided by b. Okay? If r equals 0, then GCD AB should be b. Otherwise, GCD AB should be GCD BR. Okay? This is a mathematical definition of a recursive call. So similar to the previous examples, you can declare the function for GCD like this. The argument is the two arguments, a and b. A should be larger than b. And you have to calculate the r. This is a remainder of a divided by b. Okay? So using percent operator, you can calculate such a value. So if r equals 0, the return value should be b. So because this is definition. Okay? Otherwise, the return value should be GCD BR. This corresponds to this definition. Okay? So the lower part is the main function. So some cases, recursive function is very convenient, useful. So it's better you can use such a recursive function. So this is the first part exercise. Please input the example program I introduced, and please check the results execution behavior. Okay. So okay, can I shift to the second content? Okay. So second content is introduction of the concrete application. So in this content, I introduced two concrete example program. One is a binary search program, and second one is a sorting program. Especially, I introduced a quick sort algorithm. So if you have the data, such data is stored in array type data, like this. And of course, originally, this data, array data, should be sorted in descending, no ascending order. So binary search, in binary search, you have to find the given data is exists inside the prepared data. One, your program have to check the given data exists or not in the prepared array data. Okay. So this is an example. So initial data, other initial data, V0 is 0, V1 equal 2, and V5 is 10. And the given data is 6. So this case is your program have to return the 3 because the 3 is the location of the data that is matched to the given data. Okay. So another example, a given data is 8. 8 is matched to this data. So the location is 4. So this program should return 4. And if you give the 5, in this case, the prepared data does not include the 5. So this program should return any value beside the index. So for example, in this case, it's for example -1. Okay. So this behavior is a search program. So search program is very important, very useful. As you understand, if you have the your friend name list, if you want to his address or some information about him, his or her information. So in such cases, you have to find corresponding person, corresponding friends from the such list. If you have the many friends, so it's difficult to find your corresponding friends manually. So such case, program is very important. So this is a very simple search program. So if you have the n data, so using for loop sentences, you can check the given data is equal to the one of the prepared data. If the program finds the match data, this program can return the index as a result of the search. Otherwise, it should return -1. Okay. So this is a very simple program. That's shown here. So in the worst cases, execute it n times. This part will be executed n times. Okay. For example, n match data of n is located in the last element. So in such cases, you have to calculate this part n times. So in the average, so half n times necessary. So if n is very large, so this program is not so efficient. So one of the efficient search algorithm is the binary search algorithm. Okay. So prepared data is shown here, same as the previous one, and n is will be given, and the program will find the same data from the prepared data. of x. Okay, so this is a execution process of the binary search programs. Okay, so if n if x is less than v3, so first you have to select the midpoint data. Okay, the center position data. In this case, v3. If the given data is less than v3, so already this prepared data is sorted in ascending orders. So this given value is less than v3. So match data with this should be located this before here, before this. Okay. So otherwise, x is larger than v3. The x match data of x should be located this part. And otherwise, x is same as v3. In these cases, the program immediately returns the number 3, integer 3 as the result. Okay? So next, if the first case is true, the candidate data are only 3. This case is also the program first select the center position data and check the x is less than such data larger than or equal. Okay. So gradually, as shown here, so program can find the x is match with one of the array data. Okay, can you understand? So actual case. So initial data is here. V0 equals 0, V1 equals 2, V2 equals 4. Okay? So if x is, for example, 5, so if x equals 5, this is the false, and this is the true. Okay? So this part will be executed. So next, program have to check the V4 and V5. The center position data is 5, V5, and also check the less than or larger than. The 5, V5 is a 10, so this is true because 5 is x is 5. And the remaining data is V4. Okay, so the program have to compare x and V4. So however, this is not match. So the program returns the no match result. Okay. But in fact, the 5 is not included in the initial data. So next case is, for example, x is 6. So if x is 6, the V3 is 6. So this case is this is true. So the program can return the integer 3 as a result. Okay, and 0. If the x equals 0, this case is in this case this is true, and 0, 2, 4, and this element will be selected, and the program compare x with this element. So x is 0, so this will be true. Okay? And the remaining element will be 0. And the program compared this element and x. The x is 0 and v0 value is 0. So the match. So this program return the integer 0 as a result. Actually, the 0 is the location of the corresponding data. Okay? You can understand? Okay? So as shown here, the important thing is here, comparison operation like this will be executed log 2 n times. Okay? So this is very efficient, and this means very efficient. Efficiency means efficiency of this program. Okay? So if n is very large, so this value is very treated as very efficient value. Okay? So in program, so anyway you have to declare as such algorithm, previous algorithm as a program. So this is a simpler program. So you have to search x from the 6 data. Okay. So this is the main part. If given data is center position data, if given data is less than center position data, you have to also search x in smaller parts, smaller data, rather than center position. Otherwise, x is equal center position data. So in this case, this program can immediately return integer 3 as a result. Otherwise, you have to also search x from the remaining data. And that means larger data than V3. Okay? So using loop sentence or recursive call, you can calculate also this part. So this is the actual program for binary search. This is a prototype definition for binary search program. Return type is the integer, and the function name is the binary search, and the argument is 3. Arguments are 3. The given data and array data of integer type, and the number of array size. Okay. And this is the main program. The next page includes the actual program for binary search. Okay. So the program is completely the same as the content of I explained before. So it's better to check manually the algorithm of binary search by yourself. Okay. And next, the last example is a quick sort. The quick sort is a very convenient program. As I explained, the sorting program is a very convenient and useful. And especially quick sort is a very efficient sorting algorithms. The sorting program have to sort the n data in any order, ascending or descending order. If you have this kind of data, array data, quicksort program should be return this array data in ascending order. So this part shows the simple algorithm of a quicksort. Okay. So this is the initial data, array data. this order, 305214. So this program should make this order like this, 0, 1, 2, 3, 4, 5. And first, this program select the first element. Okay. So this program compares remaining data with these values. If the comparison result is less than, if the data is less than 3, okay, the program collects such a data like this, and also this program collects the data. These data larger than 3. Okay. Okay, this is the first step. Okay. First sorting algorithm selects one data, and the remaining data is divided to two parts. Less than this data part and larger than data part. Okay. Like this. After that, the same process will be applied to each part. Okay? So one selects one data, and remaining data will be compared to this data and divided to two parts. Okay? Okay? So this is also same. So in this way, the gradually, so this order will become like this. Okay, so maybe you can imagine this part is the same operation will be applied. So if you make a program for quicksort program, you can define using the recursive call. Okay. So the following several pages, the actual program will be shown. So first you have to define the swap functions. So because the sorting program needs a swapping operation. Okay? So in this cases, position I data and j data will be swapped. Okay? Swap means exchange. And this part is a quicksort function. Okay? So the position last means the position of the selected data. Okay? So quicksort. So this is just a moment. So actually, the calling function for quicksort is here. A quicksort. Okay, the array data and the data size. And inside this, if n is the data size is less than 1. In these cases, you don't need any sorting against this data. Otherwise, a quicksort program will be called. Okay? So in this case, you have to specify the 3 data, array data, and left position and right position. So first you select any value, and remaining data divided by 2 parts, less than this, larger than this. And recursively, this part will be selected, and remaining data should be divided larger than this or less than this. Okay? And So in this way, recursively, this operation will be applied to the corresponding data. Okay? So you have to specify, when calling quicksort algorithm, you have to specify the left and right position. Okay? The left and right position. Actually, left position, right position, left position, right position. Okay? So actually, this part is correspond to actually this part. Okay? And after that, two quicksort will be called. Each correspond to the less than part and the larger than part. Okay? So last, it corresponds to these positions. Okay? Okay? So this part is completely same content as I explained. First, you select this part. Okay? So initially, last, it corresponds to this position. So once you have to swap. Okay? So compare each remaining data one by one with this data. And you can correct for larger part, larger than part or less than part, less than part or larger than part, using this part. Okay? So anyway, as I explained, it's better to check manually how this program will be executed by yourself. So last part is actual main function. Okay. So this is the end of the today's content. So please, as shown here, please input exam program introduced before and check the behavior of such program. And remaining data, remaining time, please spend for the preparation of the exercise report or homework report. Okay?